Hello, my name is Miłosz, and today I'm going to tell you how serverless is going to make programming great again. Let me begin with a quick question. How many of you have heard about serverless? You see, the topic is quite popular. In this presentation, we will see why. Just a few words about myself. My name is Miłosz. I'm a passionate web developer. I've spent a couple of years working in London in an investment bank, and currently I work at 7N. I have built systems in different technologies such as .NET, JavaScript, and Scala. And I have deployed them to various cloud environments such as Azure and AWS. But today we'll talk about serverless architectures. Why did I decide to talk about this particular topic? I run a programming blog, and I wrote a post about serverless. And this post turned out to be the most popular one on the blog. Besides, I strongly believe that serverless is a revolutionary concept, and it will change how systems are built. So, what is serverless? The key concept behind serverless is that when building an application, you no longer need a traditional application server, a traditional backend. So, what do you do instead? You have two options. You can use backend as a service approach and frontend as a service approach. What's backend as a service then? Backend as a service, in the backend as a service approach, instead of building the traditional application server, we use existing third-party components to implement functionalities that are very similar across different applications. So, for example, authentication is a good example. And how about function as a service? So with function as a service, you can still deploy some custom logic, some custom business logic, implement it and deploy it, but without building a full-blown application server. So the way it works is just you write a small piece of code, a function, and give it to your service provider to run the code for you. It's easiest to understand serverless when comparing with the traditional architecture. So here on the diagram, we can see an example of a traditional system with a client, a database, and a big application server in between. So whenever the client wants to read some data from the database, it has to ask the application server first. And also when the client wants to write some data to the database, the data has to go through the application server. And the application server can perform some validation, for example. Are there any problems with this approach? Unfortunately, there are. Because if you want your application to be scalable, the only option you have is to deploy multiple instances, multiple copies of this application. And you need to do a lot of work to make this work. Like, for example, you need to set up load balancing. And another problem is that with your application, if you want it to be able to handle these big spikes in traffic, you need to maintain this whole infrastructure, but it's not used all of the time. There are some periods when it's not used at all, when it's idle, but you still incur the cost. You have to pay for the hardware, and you have to pay people who maintain it. Another problem with the traditional approach is that you need to, as I mentioned, there are some components that are very similar across different applications, such as authentication, data access, data validation, or monitoring. And you have to waste your time implementing these components over and over again. Finally, with the traditional approach, you have to have expertise both in front-end and back-end technologies, which are completely different worlds. And if you're a company owner, for example, it's expensive to hire developers with both expertise in both front-end and back-end technologies. So that's, whoops. Yeah. Now let's compare traditional architecture with serverless. So we have a client, we still have a database, but in between, instead of the application server, we have some components. And the component at the top is an example of the backend as a service approach. So this component implements authentication. And we don't implement this component ourselves. Instead, we use an existing third-party component. It's very convenient. This component out there is well tested, proven to work, so it's a good idea to use such an existing component. And at the bottom, we can see a couple of functions. So this is an example of the function as a service approach. So if we have to implement some custom business logic, we can still do this with serverless, with function as a service. As I said, we just write these tiny or big pieces of code that implement some business logic and deploy them to the service provider. So what are the benefits of serverless then? Obviously the costs, operational costs, because you no longer need to maintain this large infrastructure and pay for it and pay people who maintain it. Costs of scale, because you only pay for the actual usage of the application, for the actual execution time. You don't pay, as is the case with the traditional approach, for the time that your infrastructure is doing nothing. Cost of development, because you don't spend time developing these components that are similar across different applications. And also, you don't need expertise both in backend and frontend. From the developer's perspective, serverless is pretty awesome because you can finally focus on code. You don't need to worry about how to deploy your application. You don't need to know anything about virtual machines, servers, load balancing, and all this stuff that's, for some developers, it's not very exciting. You can focus on the fun stuff, writing code. And finally, if you are a business owner or startup owner, or you just simply have an idea for an application, serverless is perfect for validating such an idea, because you don't need to incur this initial investment into infrastructure. You can just start using different serverless services offered by different providers, and these services are usually for free, so you don't need to pay for them initially, of course. If your application scales and suddenly you have lots of users, of course you have to start paying for it. But when starting building an application, it's just perfect. It's for free. Although serverless is relatively young, it has already been adopted by a couple of big names. You can see some of them on the slide. But let me focus on the on the use case of Coca-Cola. Coca-Cola has this loyalty program. So when you're buying Coke, you get some loyalty points and you can collect them and exchange them for some rewards. So Coca-Cola decided to implement this use case with serverless. Whenever you go to a vending machine to buy a bottle of delicious Coke, the vending machine calls a function deployed in AWS Lambda, which is an example of function as a service provider. And this function, this is just a piece of code. It processes your transaction and it pushes back the information to your phone so that your phone knows about all your loyalty points, all your rewards. And how did it work for them? They managed to reduce costs of maintaining the infrastructure to support this use case from $30,000 a year to $4,500 a year. And what's interesting, when they calculated the cost of maintaining the traditional architecture, they not only considered the costs of hardware, they also had to consider all the costs of all the money they pay to people who maintain the hardware, who install patches on servers, who maintain all the networking and all that stuff. And what's also worth noticing here is the volume Coca-Cola is coping with, 30 million hits. I think it's pretty impressive, and it shows that serverless can actually cope with huge volumes. Okay, we've talked about what serverless is. Now let's see how we can implement it and what kind of tools can we use. I will start with Firebase. Firebase is an example of backend as a service provider. They have a long list of components that they provide, but I will talk about just two of them, authentication and the real-time database. I already mentioned authentication as an example of a component that's very similar across different applications. And how many of you had to implement some authentication mechanism at least once? Yeah, I see many hands, so you know what I mean. It's not very exciting task, and there is a lot of possibility of error, right? And security errors, for example. So instead of implementing it over and over again, what we can do is use Firebase authentication. This is simply a web service available somewhere in the internet, in the cloud, that we can call to register users, to verify if a user is authenticated, to reset password, and things, all these common operations related to authentication. And as I said, it's there, it's well tested, it's proven to work, so why not use it? What's also very cool about Firebase authentication is that they provide a library that implements all the user interface for authentication. So all the login forms, registration forms, and reset password workflows. So you don't need to implement it yourself. You can just use Firebase authentication and customize it. And finally, what's also an advantage of Firebase authentication is that they integrate with different authentication providers. For example, Google, Facebook, or Twitter. Okay, now let's talk about the real-time database, which is another service provided by Firebase. So, as I said, with serverless, we no longer have this intermediary layer between the client and the database. And in the traditional approach, this application server would perform data validation. So whenever we put some data in the database, it would always go through the application server, and the application server would be able to perform some validation. So now in the serverless world, we need to cope with this situation because we no longer have the application server. We need a special kind of database that will have validation built in, and that's exactly what Firebase real-time database does. You can declaratively define rules of what data can go into it and what data can't. There is another interesting property of Firebase real-time database. It's real-time. So whenever one of the clients writes to the database, the data is automatically propagated to other clients. And it will also save you writing a lot of boilerplate code, right? Because there are common scenarios in which you have to poll for data or use some WebSockets or things like that to have always the most recent copy of data. And in Firebase, it's just built in. I mentioned validation rules. So just to give you an idea, this is how they look. Firebase is a NoSQL database. So you basically store JSON objects in it. And here is an example of a validation rule in which we say that there is a collection called contacts, and whenever you want to write something, to push something into this collection, this object has to have two fields, name and age. And name has to be a string, and age has to be a number. Great. We talked about tooling related to backend as a service. Now, let's have a look at function as a service. And before that, before I mention any tool, let me just put function as a service in the wider context of the cloud, because I think function as a service can be looked at as the next step in the evolution of the cloud. So firstly, we had on-premise, big data centers, and every company had to maintain their own servers, their own data centers. Then infrastructure as a service came. And with infrastructure as a service, instead of maintaining your own data center, you just rented machines from another company, such as Amazon or Google or Microsoft. And they gave you access to some virtual machines which you can create on demand or destroy on demand. Just pretty cool. But still, when thinking about scaling, you had to do a lot of work. Like you had to set up all these virtual machines, deploy various instances of your application on them, set up load balancing, do all these things. So platform as a service came, where you don't have to do this. Instead of thinking in terms of virtual machines, you think in terms of applications. So you build a whole working web application, deploy it into the cloud, And that's it. You can say how many instances of this application you need to run. And all this setup, all the load balancing is done for you. That's already pretty good, but we can do better with function as a service, because with function as a service, the responsibility to scale our application, it's no longer our responsibility. It's the responsibility of the service provider. We just deploy these functions, these pieces of code, and whenever large peak in traffic comes, like 10,000 users start using our application, it's the responsibility of the service provider to start up all these instances needed to handle this big traffic. And when it's no longer needed, these instances are killed, and you only pay for the actual execution time. There are many function as a service providers. I already mentioned AWS Lambda in context of Coca-Cola. There is also Microsoft Azure with functions. Even Firebase has its own service called Functions. But let me talk quickly about Webtask. Webtask is very interesting because it's extremely easy to start working with. You can just install their command line tool and type a command to take a JavaScript file and deploy it in the cloud. You get back a URL which you can paste into the browser, hit enter, and suddenly Webtask is executing your code, which I think is pretty cool. I talked about function as a service and backend as a service, but in the context of tooling, I think there is one more component that's worth talking about, and it's the client side, because it has to change a little in the serverless world. With the traditional approach, we had a relatively thin client and a huge application server. It's huge because all the business logic, all the complexity is in there, usually implemented with some technology such as Java or .NET. And in the serverless world, we no longer have the application server. Instead, we can put some of the business logic in the functions and deploy them using function as a service. However, still a lot of logic will probably go to the client. So now we need some way to manage all this complexity in the client side. And with the older JavaScript technologies in the web world, it wasn't very easy and well suited for building complex clients. However, Angular 2 comes to rescue and other similar frameworks. With Angular 2, which is based on TypeScript, it's much better suited for building complex applications, right? Because TypeScript, first to begin with, TypeScript is a statically typed language. So it eliminates a whole classes of bugs that you can make in your code. And also it's a framework which introduces some design patterns such as dependency injection, and it structures your application. You have to split it into components, services, and modules. So basically it's pretty good for managing complexity. Great, I think we have all the theoretical background ready for a quick demonstration. And in this demonstration, I will show you how I created a working serverless application just in 7 minutes. The goal of this application is, it will be an application for submitting questions for conference. So I will deploy it and you will be able to use it to submit questions, which I will answer after this presentation. And there is a little twist. All the questions have to be correctly spelled. So we will be doing some spell checking. How are we going to implement it? There will be a client in Angular. There will be a database, a Firebase real-time database. And the client won't be adding questions directly to the database. Instead, it will be calling a web task. And this web task will perform validation, the spell checking, right? So for that, we'll call another backend as a service. It's called after the deadline com, and it's a simple web spell checking API. So let me run the demonstration now. It's actually a screencast, but I will be talking about what's going on. Okay, so we start by logging into Firebase console. We just need a Google account for that, and it's completely for free. We create a new project, called it Code Europe QA. Now we can go to the database section of Firebase console and see that the database is obviously empty. Now let's go to the validation rules section and let's get rid of the default rules, because for now we just want everyone to be able to write to this database, just for simplicity. Now let's launch the terminal and install a couple of node modules. We'll start with Angular CLI, which is a command line tool for generating a skeleton of Angular application. Now we can use this tool by typing ng-new to generate a skeleton of our project. It generated lots of files. So let's go into this newly created directory and install two more modules. We'll install the Firebase module and Angular Fire 2 module. Both will be used for communication between the client and Firebase. So that's like an SDK, Firebase SDK for Angular. Okay, let's now open Visual Studio Code, which is a code editor. And let's have a look what Angular CLI generated. So we can see a big directory structure here. Let's create some files. I will start with the domain model for the application. So a file in which I will declare the objects that will be used across the application. There will be just two of them. The first is an interface for questions. So the object that will store in the database. It has just two fields, content and timestamp. And the other interface, it will be a command for adding new question. So an object that will be exchanged between the client and the web task. Now let's create another file in which we'll store configuration. And this configuration will be used by the client to connect to Firebase, because it has to know which project to connect to and some API keys. We can find all these values in the Firebase console and just copy them. Great. Now, you remember I installed a couple of Firebase modules. So now let's import them and add them to the main module of the application. We should initialize the Angular Fire module with the configuration we have created in that file just some seconds ago. Now let's generate a component, Angular component. Let's call it questions. It will be responsible for displaying questions and for adding new questions. So we inject Angular Fire database, which is part of the Angular Fire SDK. And using this database, we can bind a field in our component to a list of questions in the cloud, in the database. And the type of this field is Firebase list observable. It's an observable because the data is real-time, right? We always get the most recent version of data. Now let's create a method for adding questions. It takes the content of the question and simply pushes it into the database. So we don't perform validation yet. We'll add validation in a moment. Now all is remaining is to add some HTML just for the user interface. It's not very exciting, but has to be done. So at the top we can see the form for adding questions, and at the bottom we bind to this observable list of questions. And thanks to some Angular magic, it will automatically update whenever a new version of questions comes. Now we need to add this component to the main app component, and finally we will add a Bootstrap CSS style sheet for look and feel. Now again, using Angular CLI, we can start up a development server and see our application in action on localhost. Here it is. So let's type something. and click on add, and you can see it works. It appeared on the list. Now let's take a look at the Firebase console, go to the database section, and we can see that the database is no longer empty. What's very cool, we can even modify this data in place. So I just change cool to uppercase, and you can see it updated without a page refresh. Okay, let's now add validation, because for now the client writes directly to the database. For that we need a web task, as you remember, right? So this is the code of the web task. It's pretty long, but it's actually simple. It just makes two web requests. The first one is to the after the deadline API to do the spell checking. And if the result is successful, we make another call to the Firebase database. And we basically add the question to the database. So now just some maintenance. We need to compile this file because it was in TypeScript, so we need to compile it to JavaScript. Next, we need to create a bundle to take this file and all its dependencies and combine them into one single file, because Webtask only accepts a single file. And now using the Webtask CLI, which I talked about, we can create a Webtask from this particular JavaScript file. We come back a URL. So whenever you hit this URL, Webtask will execute the code that's there. So now let's modify the application slightly. And instead of pushing directly to the database, we will call this web task. Great, we can try ng-serve again, so run the development server and see the application in action. Let's now type something that's not correctly spelled and try adding it. And you can see we got an error. Now let's try something that is correctly spelled. And hooray, it's working. Okay, let's get back to the presentation. Now, as I said, this application is available online. So I really encourage you to take a moment, type this URL into the browser, or you can use the QR code and type some questions. So let's just wait a few moments until I can see some people doing that. Yeah, I can see that some people are using QR codes, actually. That's good. Of course, if someone prefers, you can also ask traditional questions in a traditional way. Just a few more seconds and we will move on. Okay. While you're typing your questions, let me tell you a quick story about how serverless allowed me to implement one of my ideas for a side project for a small business and validate it in a real world to get some feedback from real users. The application is called Friendtainer, and I had this idea to create a web/mobile application that will remind you to meet with friends regularly. And I had this idea somewhere in February. I spent March on implementation. I used Angular on the client, the Ionic framework for the mobile look and feel. I used Webtask for sending reminders to users. I also used a lot of components from Firebase, authentication, Google Cloud Messaging for push notifications. And what's cool, I haven't paid a single $1 for this. So because all these services had some free plans that I could use, and there are some, of course, there are some limits of usage, but they are pretty generous and you can do a lot for free. And I spent like 50 hours in total on implementation, also because I didn't need to build separate front-end client and back-end. I did everything in Angular and TypeScript. And somewhere in April, I deployed the application, and after just a couple of days, I've got 100 registered users and a lot of feedback. So why am I telling this? To let you just to let you know that serverless is really well suited for such situations. if you have some idea for a project, if you're a startup owner or a bigger company that wants to prototype a product or an idea for a product, with serverless, it's just amazingly quick, and what's important, it's for free. You don't need to make any initial investment. But what's also important, if your application turns out to be successful and suddenly you get like 10,000 users, like the so-called hug of death, then Firebase and Webtask, they're very scalable, so they will be able to handle all this big traffic. Okay, we are almost at the end. Just a couple of references, so if you're interested, you can take a picture of that. So we had a GitHub repository in which I put the source code for the application that was implemented during the demonstration. Below, there is a GitHub repository for Coca-Cola. They have lots of samples for AWS Lambda and also the accompanying setup. Next, there is a very nice article about serverless by Martin Fowler, in which he describes a lot of the background and theory. Next is a presentation, again by Coca-Cola, in which they talk a lot about how they use serverless to implement their use cases. Finally, we have a link to my blog, in which I write a bit more about serverless, and a link to the application I talked about if somebody is interested.